You ever have one of those brilliant three-dimensional ideas in your head, but then you struggle to get it down on a flat piece of paper? Well, today we're diving into the essential toolkit for doing exactly that, turning complex 3D concepts into clear 2D drawings that anyone can understand. Let's get into it.
All right, so here's our game plan. First, we'll tackle the fundamental challenge of representing 3D and 2D. Then we'll get into our two main tools for the job, looking at the quick and easy oblique sketch, and then the super common isometric sketch. And we'll wrap up by seeing how even the most complex shapes are really just made from a few simple building blocks.
Okay, let's start with the problem that every inventor, designer, and engineer runs into. It's that classic challenge. How do you take a living, breathing idea in 3 dimensions and squish it onto a flat surface, like a screen or a piece of paper, without losing its magic? I mean, that's really the big question, right? You've got that spark, that new product, that awesome design, and it exists perfectly in your mind's eye. But to actually build it, to share it, to make it better, you've got to draw it first. So how do you do that without losing what makes it special? Well, the answer, thankfully, has a name: a pictorial sketch. Now, this isn't your standard, flat, front-view drawing. No, this is a special kind of sketch that's designed to show all 3 dimensions. We're talking height, width, and depth all at once in one single, super easy to understand view. So why should you care? What's the big deal? Well, these sketches are basically a universal language. They're awesome for showing an idea to a client or a manager who, isn't an engineer. You see them everywhere, from IKEA assembly instructions to slick marketing materials. And maybe most importantly, they actually match how we naturally picture things in our heads, which really helps us understand how all the parts are supposed to fit together in space. So we know why these sketches are so critical, but the real question is, how do we actually make them? Well, it really boils down to 2 main methods, or, tools in our toolkit for projecting a 3D image onto a 2D surface. And this is where you face a fundamental choice. On one hand, you have parallel projection. In this world, parallel lines on the real object stay parallel in your drawing. It's pretty easy to do, but yeah, it can sometimes look a little funky, a little distorted. On the other hand, there's perspective projection. This is where lines race off to vanishing points on the horizon, just like in a photograph. It looks incredibly real, but man, it is so much harder to draw accurately. So for our toolkit today, for getting ideas down quickly and clearly, we're going to stick with the much more practical and accessible method: parallel projection. And within that world, we're going to master the 2 most important techniques you'll ever need: oblique and isometric sketching. Let's kick things off with our first tool, the oblique sketch. Seriously, think of this as your go-to for just getting an idea on paper, like right now. It is by far the simplest type of pictorial you can possibly create. The magic of an oblique sketch is all in its front face. You draw it straight on exactly as you'd see it with 0 distortion. Circles are perfect circles, right angles are right angles. The whole 3D effect comes from these depth lines that you just shoot back at an angle. So here's a pro tip. If your object has a really complicated face with lots of curves or holes, make that your front face. Trust me, it'll make your life way easier. And the process? It's honestly that simple. It's just 2 steps. Step 1, draw the front of the object like it's a totally flat 2D drawing. Step 2, from each corner, just draw parallel lines going back at an angle. And bam, you've got the illusion of depth. That's literally it. Now, even within oblique, you get 2 flavors to choose from. First, there's Cavalier. That's where you draw the depth lines at their full, true length. Super easy, but it often looks kind of stretched out and distorted. For a much more realistic look, you go with the cabinet method. All you do is cut the length of those depth lines in half. It's a simple little trick, but it makes the object look way more accurate and proportional. All right, so if oblique is the quick and dirty tool, our second tool is the industry workhorse. This is the one you're going to see most often in technical drawings and design sketches, the isometric pictorial. The name itself kind of gives away the secret. Iso means equal, and metric means measure. In an isometric drawing, the 3 main axes, the ones that represent height, width, and depth, are all equally spaced out, with exactly 120 degrees between them. It's this equal spacing that gives the drawing that really balanced, clean 3D look. Okay, so here's how this actually works in practice. And this is super important. Height is always drawn straight up and down, vertical. But the width and depth, they're drawn on axes that are angled up at 30 degrees from the horizontal. And here's the big difference from an oblique sketch. There are no true faces here. Every single surface is distorted. Every circle becomes an ellipse. It's a complete but very convincing illusion. The drawing process is totally different too. Instead of starting with one flat face, you have to think more like a sculptor. First, you lightly sketch a bounding box, a glass cube, basically, that represents the object's total height, width, and depth. Then you start carving away. You block in the smaller features and cutouts inside that main box. You always save the tricky stuff like curves and ellipses for the very end.
So let's just boil this down to the key trade-off you need to remember. With Oblique, you get that amazing gift of one true face with zero distortion that makes it super easy to draw circles and complex shapes on that one surface. With Isometric, you give up that luxury, but you get a more uniform, professional-looking 3D view where all the faces are equally distorted. Okay, so we've got our two main drawing tools down. But this last section is about something a little more fundamental. It's about a different way of seeing. You see, the secret to drawing any complex object is to stop seeing it as complex and start seeing it as just a pile of simple shapes. This is such a powerful way to think. I mean, look at a car, a coffee maker, a computer mouse. They seem incredibly complicated at first, right? But if you really look, if you squint a little, you'll see they are all just built from a handful of simple, foundational geometric shapes. And here they are, the absolute building blocks of 3D visualization. We call them solid primitives. You've got the box, the cylinder, the cone, the sphere, and the wedge. With just these basic forms, plus the ability to, say, extrude a flat shape into 3D or revolve a curve around an axis, you basically have the complete Lego set for building almost anything you can possibly imagine. Now, it's not just about having the blocks, right? It's about what you do with them. And there are really only three basic operations. You can add them together, like you're welding two pieces of metal. You can subtract one from another, like drilling a cylindrical hole out of a box. Or you can find where they intersect, which is super useful for figuring out how two different parts are going to fit together. And that's the whole system. Seriously. So next time you're trying to sketch something that looks complicated, don't get overwhelmed. Just ask yourself two questions. What simple primitives is this thing made of, and are they being added, subtracted, or intersected? This approach just simplifies everything. Which kind of brings us full circle, back to the ultimate goal here. Sketching isn't about creating a perfect masterpiece for a museum. It's about having a tool for thinking on paper. It's, as the quote says, a rough, freehand drawing used to document, communicate, and refine ideas. That's what it's all for. So there you have it. You've got the toolkit, you've got the methods, Oblique for speed, Isometric for detail, and you've got this powerful mental model of building with simple shapes. The only question left is, for that next brilliant idea that's going to pop into your head, which tool are you going to grab first to bring it to life?